Today we will learn unconfined compression test. Scope of the test. The primary purpose of this test is to determine the unconfined compressive strength, which is then used to calculate the unconsolidated undrained shear strength of the clay under unconfined conditions. According to the ASTM standard, the unconfined compressive strength QU is defined as the compressive stress at which an unconfined cylindrical specimen of soil will fail in a simple compression test. In addition, in this test method, the unconfined compressive strength is taken as the maximum load attained per unit area or the load per unit area at 15% axial strength, whichever occurs first during the performance of a test. Standard reference ASTM D2166 Standard test method for unconfined compressive strength of a cohesive soil. Significance: for soils, the undrained shear strength SU is necessary for the determination of the bearing capacity of foundations, dams, etc. The undrained shear strength SU of clays is commonly determined from an unconfined compression test. The undrained shear strength SU of a cohesive soil is equal to 1/2 the unconfined compressive strength QU when the soil is under the F is equal to 0 condition. Phi is equal to the angle of internal friction. The most critical condition for the soil usually occurs immediately after construction, which represents undrained conditions. When the undrained shear strength is basically equal to the cohesion C, this is expressed as SU is equal to C is equal to QU by 2. Then as time passes, the pore water in the soil slowly dissipates and the intergranular stress increases, so that the drained shear strength is given by S is equal to C plus sigma 10 phi must be used, where sigma dash is equal to intergranular pressure acting perpendicular to the shear plane and sigma dash is equal to sigma minus U. Sigma is equal to total pressure and U is equal to pore water pressure. C dash and sigma dash are drained shear strength parameters. Equipment: compression device, load and deformation dial gauges, sample trimming equipment, balance, moisture can. Test procedure: 1. Extrude the soil sample from cell by tube sampler. Cut a soil specimen so that the ratio L by D is approximately between 2 and 2.5, where L and D are the length and diameter of soil specimen respectively. 2. Measure the exact diameter of the top of the specimen at 3 locations 120 degree apart, and then make the same measurement on the bottom of the specimen. Average the measurements and record the average as diameter on the data sheet. 3. Measure the exact length of the specimen at 3 locations 120 degree apart, and then average the measurement and record the average as the length on the data sheet. 4. Weigh the sample and record the mass on the data sheet. 5. Calculate the deformation dl corresponding to 15% strain E. Strain E is equal to del L by L naught, where L naught is equal to original specimen length as measured in step 3. 6. Carefully place the specimen in the compression device and center it on the bottom plate. Adjust the device so that the upper plate just makes contact with the specimen and set the load and deformation dials to 0. 7. Apply the load so that the device produces an axial strain at rate of 0.5% to 2% per minute, and then record the load and deformation dial readings on the data sheet at every 20 to 50 divisions on deformation the dial. 8. Keep applying the load until 1. The load dial decreases on the specimen significantly. 2. The load holds constant for at least 4 deformation dial readings, or 3. The deformation is significantly past the 15% strain that was determined in step 5. 9. Draw a sketch to depict the sample value. 10. Remove the sample from the compression device and obtain a sample for water content determination. Determine the water contents as in experiment 1. Analysis 1. Convert the dial readings to the appropriate load and length units and enter these values on the data sheet in the deformation and total load columns. Confirm that the conversion is done correctly, particularly proving dial gauge readings conversion into load. 2. Compute the sample cross-sectional area. Analysis 1. Convert the dial readings to the appropriate load and length units and enter these values on the data sheet in the deformation and total load columns. Confirm that the conversion is done correctly, particularly proving dial gauge readings conversion into load. 2. Compute the sample cross-sectional area. A naught is equal to pi by 4 d square. 3. Compute the strain. E is equal to del L by L naught. 4. Compute the corrected area. A dash is equal to A naught divided by 1 minus E. 5. Using A dash, compute the specimen stress. SC is equal to P by A dash. Be careful with unit conversions and use constant units. 6. Compute the water content W%. 7. Plot the stress versus strain. So, QU as the peak stress or at 15% strain of the test. Be sure that the strain is plotted on the abscissa. Figure 12.1 shows you compressive stress versus axial strain. 8. Draw more circle using QU from the last step and show the undrained shear strength SU is equal to C or cohesion is equal to QU by 2. Figure 12.2 more circle.